Hello and welcome to another session in this IBDP MAIHLSL course. And today we are going to talk about SL 5.4, which is finding the equation of tangent and normal line to a given point and their equations. So let me tell you how to find the equation of a line passing through a given point and having a given slope. M is the slope of a line, general line, and it is passing through a given point, say x1, y1, then the equation of that line is given by y minus y1 equals m times x minus x1, right? Also, if two lines are parallel to each other and let's say they have the slopes m1 and m2, so m1 must be equals to m2 if two lines are parallel. But if two lines are perpendicular to each other, means they makes 90-degree angle with each other. So in that case, let's say slope of one of the line is m1 and slope of other line is m2, then the product of their slopes must be equals to -1. Okay. Now, let's talk about how to find the equation of tangent and normal line to a given point, right? Now, let's consider a function whose graph is given by this and its equation is, let's say, y equals f of x. Okay. Now, we know if we find the derivative of this, we can say y prime is equal to f prime x, which is also the slope of tangent line at that point, right? In order to find the equation of a line, we need only two things, slope and passing through a given point. So slope of tangent line is given to us. Let's say there's a point, let's call that point as P, and let's draw a tangent line to that curve here. This is the point P, x1, y1. Okay. So we have the slope of the tangent line at that point only. Let's call this as M. Okay. So now we can easily find the equation of this tangent line using y minus that point y1 equals m times x minus x1, where m is what? M is the slope of the tangent line at that point x1 y1 dy by dx value. Now, that's the equation of the tangent line. But if we need the equation of normal line, what do you mean by normal line? Normal line is a line which is perpendicular to the tangent line. Okay. And one more thing, tangent line is a line which touches the curve at one point, but remember it can cut the curve at any other point also. Okay. So if it is tangent, means we say tangent at the point P only, right? Because it is cutting the curve at other point. So now a normal line is a line which is perpendicular to the same tangent line at the point of contact here. So this is the normal line here. Red colored line is normal line, which is perpendicular to our given tangent line. So in order to find the equation of normal line, we need the slope of normal line. And how can we find that? We know product of the slope must be equals to -1. So slope of normal line at that point must be equal to negative reciprocal of slope of tangent line, right? So if the slope of tangent line is m, then the slope of normal line will become -1 over m. So the equation will be y minus y1 equals -1 over m times x minus x1. So in this way we can find the equation of tangent line or normal line at a given point. They'll give you the point in the question itself. Okay, and they may ask you to find the slope, which you can easily calculate by finding the gradient at that point. Here is the question. It says find the equation of the tangent to the curve y equals 2x squared plus 4 square root of x at the point where x equals 4. So in order to find the equation of the line, we need two things, as I said. First thing is slope of tangent line at that point, means we are looking for dy over dx when x equals 4. So we can easily calculate that. So that's our first point. Second thing is we need the point, right? Because our tangent line will pass through a point whose x coordinate is 4. So how can we find its y coordinate? We need the point whose x coordinate is given as 4. So we also need the y coordinate of the point. So if we substitute x equal to 4 back to the original equation of the curve, yes, we can find the value of y corresponding to x equals to 4. Okay. Once we get the slope and the point, yes, we can easily find the equation of tangent line. Okay. So here I will use the d over dx of x raised to the power n equals n times x raised to the n minus 1, even if it is square root of x. So for that part, I can rewrite it as derivative of, I have root x. So I can write root x as x to the power 1 by 2, right? So 1 by 2 comes out, reduce 1 power of x. So that becomes 1 by 2 minus 1, or simply I can say half of x raised to the negative 1 by 2, or you can also write it 1 by 2 root x. Okay, so that was all about the derivative part. Okay, now let's find the equation of the tangent line. So given curve is what? Y is equal to 2x square plus 4x raised to the power 1 by 2. Now we can use the derivative function, right? This we get derivative of 2x square is 4x, and the derivative of this is coming out as this 2 over root x. Okay. Now, in order to find the slope of the tangent line, we have to substitute x as 4 here. So put x equals to 4 here to get the value, right? So x equals to 4 gives me 16 plus 2 over square root of 4. On solving that, I'm getting dy over dx as 17. So that's the slope of the tangent line. Okay. Now, next thing is that point, as I said, we need y value. So if x is equal to 4, we can substitute that x equal to 4 in the equation of the curve. We get the corresponding value of y. So we got y equals 2 times 4 square plus 4 times square root of 4, which is in this case comes out as 40. So the given point will be 4 comma 40. And now we can easily find the equation of a line passing through 4 comma 40 and having the slope as 17. So yes, simply use the y minus 40 equals m, 17 times x minus 4. And if we simplify this, we will get our answer. So that was all about finding the equation of the tangent line to the curve. Similarly, let's solve a question in which we have to find the equation of normal also. Here is the question. It says find the equation of the normal line to the curve 2x cube plus 3x minus 2 at the point where x equals to 1. Again, we need only those two things. First is we need the slope of normal line. So for finding the slope of normal at x equals to 1, we will take the negative reciprocal of slope of tangent at the same point where x equals to 1. Okay, and the second thing is we need the coordinates of a point, means we can put x equals to 1 here and we can get the corresponding value of y. So from there we can also calculate the point where our normal line is passing through that point, right? So let's find that f of 1, put x equal to 1 in this equation. We get f of 1 is equal to 2 1 cube plus 3 times 1 minus 2, which comes out as 3. And now we got a point. What is that point? X equals to 1 and y equals to 3 is a point lying on the normal line. Now we need the slope. So for that we can differentiate this, right? So f prime comes out as, for this one it is 6x for squared. For this one it is 3. So 6x squared plus 3 and minus 0. So that's the slope of normal line, tangent line. Okay, now let's find the slope of tangent line when x equals to 1. So put x equals to 1 here. What do you get? 6 plus 3 gives me 9. So now we need the slope of normal line. So what will be that? Negative reciprocal of that. It means the slope of normal line is negative 1 over 9. Okay, now let's find the equation of the normal line. Similarly, as we did for the previous question, we have the slope of the normal line, we also have the given point, which is 1 comma 3. Equation of the normal line will come out as y minus y1 equals negative 1 by 9 times x minus x1. And we simplified, we can get the equation of the line, normal line in the standard form, which on solving comes out as y equals negative of 1 by 9x plus 3 whole 1 by 9. So that's the answer. Next, this question is very important. Here we are going to find the values of some unknown, right? So it says the gradient of the normal to the graph of the function whose equation is given by fx equals to kx cube minus 2x plus 1 at the point 1 comma b is negative 1 4. The find the value of k and b. Two unknowns are there. So what we are looking for k and b. What information is given to us? Gradient of normal line. So gradient of normal line is negative 1 4th. So can I calculate the gradient of the tangent line from there? Yes, it will be negative reciprocal of that. So slope of normal line is negative 1 4th, and I can use that to say the slope of tangent line will be negative reciprocal of that, it means 4 only. That is also the value of dy over dx at that point. What is the point? 1 comma b. So x is 1, y is b. So I can use this to get the value of k first. And I will use that particular value of k because our curve must pass through this 1 comma b. So I can get the value of b. I'll show you how. So first let's start with using this slope condition. So we can find the derivative of this fx equal to kx cube minus 2x plus 1, which is f prime is equal to 3k x squared minus 2. Now it says it is uh, it is the slope of tangent line, and the slope of tangent line is what for us? 4. So equate these two. Okay. So when I equate these two, I will get this 3k squared minus 2 is equal to 4. So on solving that, I will get k is equal to 2. Now we got the k value. Okay. Thank. Second part is that it is passing through this curve is passing through the point 1 comma b. So fx is what? By the way, fx is k, which is now 2 for us. 2x cube minus 2x plus 1, and this passes through the point 1 comma b. It means I can put x as 1, then y must be equals to b. So solve this and I can get my value of b. So it gives me b equals 2 times 1 cube minus 2 times 1 plus 1. And on solving this, we are getting the value of b. Simply, we can get the values of both unknowns with the given information here. Okay. So let me show you. We are getting y equals to b, x equals to 1 gives me b value equals to 1, and hence the values of both k and b calculated. So one more question. It says for the curve with the equation y equal to 12x plus 5x to the power negative 1, first we have to find the value of dy over dx. Second part, hence find the coordinates of the point where the curve have the gradient equals to 2. Gradient equals to 2. It means the value of dy over dx must be equals to 2, and we have to find those values of x and y from here. Okay. This is find the x coordinate of the point. So we don't need y. Let's find x only. Okay. So first let's find the derivative of this. So we have y equals 12x plus 5x raised to the negative 1. We can find the dy over dx, which is for the 12x it is only 12 plus 5 negative x raised to the reduce one more power minus 2. It means we get 12 minus 5 over x square as the derivative or the gradient. Now, according to the question, it says the value must be equals to 2. So put this equals to 2 and solve for the value of x from here. So simplified, we get 5 by x squared equals 12 minus 2, which gives me 5 by x square is equal to 10. And now x square is equal to half, which gives me x equals plus and minus square root of 1 by 2. So these are the values of x. Now if they says find the uh, coordinates, both x and y values, so you can use this x value in the original equation of the curve and you can get the value of y as well. So in this way you can also get the y value and hence the coordinates of the point where the gradient is equal to 2. Okay, so if you want you can solve for the values of y. Okay, so in this session, what we have covered so far, first we saw that how to evaluate the gradient at a given point. Yes, you can also use your calculator for that, GDC. Find the point on the curve with the gradient given. Yes, the last problem was on the same thing. Equation of both tangent line as well as normal line. So we need only point and the slope. Slope is given by that gradient and point will be given to you. And hence we have seen how can we use this and how can we solve for the problems involving the tangent and normal using the technology to find the slope, right? We can simply use the derivative at that point. How to draw the graph of the gradient function, which we have already seen in the previous session also, 5.3. You can watch that as well. So that's all for today. Thank you for watching this. See you in the next part, and I'm giving you few assignment question or exercise problems that you can try by yourself. Thank you for watching this. Keep watching, keep learning.